Lovely college algebra students. We're going to start 1.6 today. 2 videos today will be solving polynomial equations by factoring and solving equations with rational exponents. The radical equations objective we will do on a different day. So let's go ahead and get started. We have done factoring by solving before with quadratics. It's going to look a little different now because now we're going to have powers higher than x squared. So our steps are to set each equal to 0, so we're going to have to get everything on the same side, factor the left side, and then set each factor we get equal to 0 to solve. So if we start this first one, I usually like to keep my highest power positive. So what I'm going to do is I'm going to subtract the 12x squared to both sides. And then I'm going to have 4x to the fourth minus 12x squared equals 0. From there, I'm going to factor out a 4 and an x squared. This is my greatest common factor. That's going to leave me with an x squared minus 3. At this point, 4x squared is a monomial. I can't factor it anymore. And x squared minus 3 is not a difference of squares because I cannot square root the x squared minus 3 nicely. So what I'm going to do is I'm going to set 4x squared equal to 0 and x squared minus 3 equal to 0. If I solve this one, 4x squared equals 0. I'm going to divide by 4. I'm actually using the square root method right now. 0, square root that, I get x equals 0. If I set this one equal to 0, I will add 3 to both sides. X squared equals 3. Square root, I get x equals plus or minus the square root of 3. There's nothing more I can do to that. So my two solutions together are 0 and plus or minus the square root of 3. Okay, I'm going to erase some of that because I'm not going to have room for this in a moment. So let me get some of that out of the way. Okay. Now I'm going to work on this one down here. It's pretty similar. I'm going to subtract 16x from both sides. This one doesn't have a GCF. It's just 3 and 16. No number can come out of both of those. The only thing I can take out as a GCF is x. So 3x cubed minus 16 equals 0. This is weird because I'm going to set 3x cubed minus 16 equal to 0. We're going to treat it kind of like the square root method. I also need to set this x equal to 0. So I'm going to add 16 to both sides on this one. So I get 3x cubed equals 16. Divide by 3. And I get x cubed equals 16 thirds. Instead of square rooting, what I'm going to have to do is cube root. Okay, so we have x equals the cube root of 16 over 3. I'm not going to ask you to simplify that any further. We're just going to leave it like this. We also have this solution down here of 0. And that's my answer. Okay, one more example of factoring. Do a little erasing again. So the next problem we're going to do at the top there, the 2x cubed plus 3x squared equals 8x minus 12. I need to get everything on the same side. Again, I want my x cubed term because it's the largest to be positive. So I'm going to subtract the 8x and the 12 from both sides. And so what I get is this. And then of course I'm going to set it equal to 0. This is 4 terms. I'm going to attempt factor by grouping. That's what we do when we have 4 terms. So, and I didn't say this, but there's not a GCF. 2, 3, 8, and 12 don't have all a common factor. So for my first set of parentheses, it looks like I have a GCF of x squared. 2x plus 3 is what I'm left with. Here I can take out a negative 4, leaving me with 2x plus 3 equals 0. X squared minus 4 times 2x plus 3. I also notice that this I can factor further. It is a difference of squares. X minus 2x plus 2 replaces the x squared plus minus 4, and then I have a 2x plus 3. So this problem is going to have 3 solutions. Set this one equal to 0, the plus x plus 2 equals 0, and 2x plus 3 equal to 0. So I get x equals, well, if I add 2, I'm going to get positive 2 here. If I subtract 2, I'm going to get negative 2 here. And then here I'm going to subtract 3 and then divide by 2. So I end up with negative 3 halves. So my solution for this third problem is 2, negative 2, and negative 3 halves. And that concludes the first video.